Hey guys, so you may have noticed that my profile picture, my icon for this channel is a picture of Euler. Okay, so I obviously think that Euler is the GOAT. Okay, Euler is definitely the GOAT. And I'll just be explaining one reason, there's many reasons, but here's just one reason why he's the GOAT. And really it comes down to this identity over here. E to the I pi plus 1 equals 0. I mean, you got 1, 0, E, I, pi, you got everything. What more could you want in an identity? All linked by such a lovely little equation here. So really just gotta love that identity. One of my favorite identities, probably no, my favorite identity of all time. Okay. And here's the identity that bounds it. It's e to the I pi is identical to cosine theta plus I sine theta. So we have these lovely little formulae for cosine and sine, all expressed in exponential form, which is really useful because you can go from exponential to trigonometric. Okay, so let's go ahead and try to prove this. Right, we have ourselves e to the theta. So these are just Maclaurin expansions. These are infinite expansions, so they do go on forever, but we can still make sense of them and use them to derive a nice little formula. So let's get started here. The first thing is I'm gonna just kind of notice a little bit that, well, they're quite similar in a way. I mean, you got the same thing. They're just kind of they're not really added up correctly. Okay, I'll show you what I mean. I mean, if I take just sine of theta plus cosine of theta, right, that's just going to give me 1, so that's this part, plus theta, which is going to be this part, minus theta squared over 2 factorial, which is this part, minus theta cubed over 3 factorial, and then plus theta to the 4 over 4 factorial, minus theta to the 5 over 5 factorial, and then plus so on. Right, so you're going to get this kind of thing going on. Oh, should be a plus, sorry. Right. And we can notice that, maybe it'd be a good way to sort of underline. So if I underline the stuff from sine is all of these. Okay, these are all the things coming from this sine. Okay, the things coming from cosine are the things that aren't underlined. Okay, in fact, actually, I can highlight it. Okay, these are all the things coming from sine. Okay, but we don't want sine. Okay, we want this to be expressed maybe a bit more nicely. Okay, so let's think about it a little bit. What happens if I kind of do what's over here? I know it's a bit of a spoiler, but I don't like these minuses going on, so how about if I just times it by I? Right, what can go wrong? So I'm going to say cosine of theta, and then I times it by I sine of theta. And all I'm doing here now is I'm just taking all of these things that are highlighted, and we're just going to add I, right? And now what I'm going to do is I'm going to go back to my equation for e to the theta. Right, we'll leave this for now. Let's just go to e to the theta. And now let's consider e to the I theta instead. Well, if I consider e to the I theta, what I'm going to get is I'm going to get 1 plus I theta squared over 2 factorial plus I theta cubed over 3 factorial plus, we'll go on I theta to the 4 over 4 factorial and so on, right? And if I simplify this out a little bit, what I'm going to get is I'm going to get e to the I theta is equal to 1 plus I theta. And then here, it's going to be negative theta squared over 2 factorial because we're doing I squared. And I squared is defined, actually I shouldn't say identity, but I squared is defined to equal negative 1. No. What about I cubed? Well, I cubed is just I squared times I, which is equal to negative I. So we can rewrite this as being just negative I theta cubed over 3 factorial I to the 4, or I to the 4, is taking I squared times I squared, which is 1, right? Because we did -1 times -1, which is just 1. So we're left with plus d to the 4 over 4 factorial. If I keep going, we're going to get I theta to the 5. I to the 5, again, you can just continue the trend. Okay, is just taking I to the 4 times I, which is 1 times I, which is I. So you're just going to be left with plus I 5 over 5 factorial. Now I hope you noticed something. This formula we have over here, well, it is exactly the same as this one. Okay, this should go on forever. But you can see it's exactly the same. All the terms just line up really nicely. The minuses all line up, and the pluses also all line up. So what we can say is you can say e to the I theta not only equals, but is identical. This works for all theta, right? If you know these Maclaurin expansions, we need to understand these Maclaurin expansions work for all real x, okay? So this is an identity. Theta can be any real value. And it should be identical to this little formula over here, cosine of theta plus I sine of theta. Now, this is known in the business as Euler's relation. It's pretty cool, right? So now what we're going to do is we're going to get Euler's identity. And all you do here is you say, well, let theta equal pi, because we can. Okay, so we get e to the I pi is equal to cosine of pi plus I sine pi. Now cosine of pi is 1. Sorry, why did I say that? Cosine of pi is -1, sorry. Sine of pi is 0, so that goes. And you can just add 1 to both sides to get e to the I pi plus 1 equals 0. And there you go. Isn't that beautiful? And that is Euler's identity. Alright, so thank you for watching, and I hope this kind of clears things up. I really do like this identity, and I think it's really cool. And we'll make more videos soon. Thank you.